Hello everyone, and I want to talk on this video about Dell Alienware 17R2 Revision R2. Now this is a really strong laptop. A very nice design in my opinion that Dell put together here. But there is one noticeable flaw that I have noticed in my shop. The actual quality control, the workmanship in Dell factories. Now this is a beast of a laptop, let me tell you. 17.3-inch glossy screen, Windows 7 64-bit, Intel i7 2720QM quad-core processor, 2.2 gig 3.3 turbo. We've got an AMD Radeon dedicated graphics card 6970M. And 8 gigs of DDR3 memory and a 1.5 terabyte hard drive. Now Dell supplies a great teardown guide, a service manual on their site. So go there to look and see how to take this laptop apart. This is not a guide. This is actually something that I'm pointing out that I have discovered from Dell. To elaborate on that, let me first say that I did receive an Alienware 17R2 Revision 2 laptop into my shop for a power issue. The laptop was not getting any power at all. Obviously I checked the power adapter and it had good voltage, and what it turned out to be was the power jack. Now what you're looking at there was I had actually resoldered that power jack back on the old board because there were cold solder joints around the power jack. So that was my attempt to resolder the joints to no avail. The board was dead. So here I've ordered another board from a reputable source. This is not a brand new board. This is a refurbished board. So the whole idea being that I'm just going to swap the board out since the original board died due to a cold solder joints on the power jack. The customer said that he had to kind of hold the power adapter in and move it around to get it to work, and that eventually ended up killing the board. It was very obvious to me looking at the original motherboard that definitely there was a factory issue with soldering the power jack onto the original board. No doubt in my mind that it was a factory issue, bad solder joints on that. So here I'm just matching up the two boards to be sure that I do indeed have the exact replica, the exact revision board. Now upon further inspection of this new board, or shall I say refurbished, watch closely here and you can see as I try to kind of move this jack around a little bit that it actually has a little bit of play. And what this indicates, let me move in there, what this indicates is that this power jack is not soldered properly to the PCB. So I'll flip it over here in a second and you can see once again that Dell has slipped up and did not solder these power jacks on correctly. So it's definitely, in my opinion, an issue that they've had on these particular boards. These laptops are about a year and a half old. You can see the solder joints that are moving around. That's just not good, not acceptable. This board has the same issue the first one did, so definitely a factory default. Not sure how many boards are affected here, but nonetheless I have to fix this. So what I'm going to do here is attempt to save this board and get this power jack properly soldered onto the board. So I'm going to start by cleaning the surface, the bottom of it, with some isopropyl alcohol to get any residual flux that may be on there. And basically what I'm going to do first, I'm not going to really add solder as of yet. I'm going to actually use my hot air and I'm going to go ahead and melt these joints as they are now before I add new solder. So we'll add some flux. Flux is your friend. Flux helps your solder to melt at the right temperature. It also helps to prevent your board from getting burnt. It also helps from melting the plastics that you see there around that area. So I'm pretty much going to have to tape the area up with some heat resistant tape, as you see here, so I don't desolder anything else around the board. So at this point now, I'm just going to go ahead and start to apply heat to these solder joints. These are the original ones. I have not added any solder yet. Yeah, so this is a prime example of cold solder joints. So the idea here is I want to melt what solder's there to try to get it to flow upwards towards the jack. This is going to help whenever I go to apply the new solder, because the original solder is already kind of flown up towards the jack and help seat the jack a little better. Now I have to say, this is my method. This works for me. You don't have to use my method if you don't want to. Actually, there's another way to do this, would be to totally desolder the jack from the board and clean all the old solder off and reattach the power jack to the board. Now what you see here is after I have reflowed the original solder, I have added more, I've touched up more solder on each joint. Now this is almost exactly what the solder job should look like, a proper solder job. So now that I've gone around and I've added new solder, I'm going to go ahead, I'm going to add more flux, and then I'm going to apply more heat with my hot air rework. And this will help to further melt the solder and work it up into those joints properly. Notice this small resistor that's right next to where I'm working. I have chosen not to cover that with heat resistant tape. This is very close to where I'm applying the hot air. Sometimes, in my opinion, and what I've practiced with, is having tape on some of the really close components, small components like that, can actually work against you if you're not careful. See, the board is laying flush right now. So even if the solder on that small component melts, that resistor is not going anywhere, provided that you're not blowing too much air and actually blow it off the board. So holding your wand at a 90-degree angle on your hot air rework is really, really important. Okay, now we're very close to getting this at the right temperature. Our flux is already activated. And we're going to complete this job by melting this solder here and working it into the joints. It's always a good idea after adding new solder before you finish your job to take your hot air and sort of do a reflow on it, what I call a reflow, to where it just kind of melts all the solder and binds it all together so we don't have cold solder joints. Okay, we've gotten that hot air done. We're going to clean off the board here, and now we're going to see how well we're connected now to the board. So as I stated earlier, I don't know how many of these M17x-R2 boards were affected by this, but there's a definite mess up at the Dell factory, and I don't know, whether it was a handful or just a few, but I happen to get 2 of them in my shop. If anyone else has had these boards come in for this same issue, bad power jack issues, let me know. I'd like to hear about it. Leave a comment. Okay, after cleaning this off, I gave that power jack a little test. I moved it around with my hands. No movement at all now. This jack is solid into this board. So I've also, gave it a little volt test. I ohmed it out, checked for resistance, so we're not shorting out either. So job well done there. Now here's the i7 for this motherboard here on the old one. I'm going to go ahead and get it swapped out into the new one. I figured I would show you guys what I use here for to remove thermal paste. It's called Arctic Clean Thermal Remover. I like it. It works really well. You just put a little bit on, like you see here. Just kind of work it around, let it sit a few seconds, and it kind of melts that thermal paste right off. I've been using it for a couple of years, and I really like it. So we'll go through and get these two dies nice and clean here. Now, another way to clean this would also be isopropyl alcohol will work just fine. So we're going to get all the residual off the top of the die, and then what I'm going to do now is I'm going to get all that gunk, all that thermal paste in between and on the edges. I'm going to get that out with just a plain old toothpick. Yay, works good for me. Just kind of scrape all that thermal paste out, get it good and cleaned up. Cleaning it off with something like a plastic or a toothpick keeps from, scratching the chip. So we definitely don't want to scratch the chip. So this is a good way to do it. Just kind of work it around, taking out little chunks. Yeah, as I'm cleaning this off, I just kind of wonder, just a thought, I wonder why, if all the heat sinks I've taken off of OEM computers, why do manufacturers use so much thermal compound? Not much thermal compound is needed, actually. A very thin layer of thermal compound is all you need. Basically just a small enough amount just to fill the small grooves and crevices that are in the heatsink, so it makes good contact. I'll show you here in a minute how I apply thermal paste. But as it stands right now, we're ready to swap the i7 chip into the new refurbished motherboard. So we'll just unlock the socket counterclockwise there. There we go. And we'll very gently pull that CPU out of its socket. Should be absolutely no force. Nice looking i7 chip there. Beautiful. No bent pins. We'll set it into the socket of the other motherboard, our newly refurbished motherboard, and we'll lock it into place. Okay, we'll swap out this one data cable here. Put it where it goes on the refurbished motherboard now. Lock it into place. Once we have that and everything's secure, now we are ready to plant this motherboard back into its original shell, its original casing. So this is kind of what was left after I tore the laptop apart. Sort of a daunting sight, given it this is almost a $1,300 laptop when it was first purchased. This, like I said before, has its own dedicated video card, and it's capable of holding actually 2 dedicated video cards, but this one only had 1. So this is what we're left with here, and we'll go ahead and get our motherboard placed in and start taking care of some wire management. Now from this point, everything just kind of goes back as it was taken apart. And you also have, as I said earlier in this video, you have Dell. They release very good service manuals. Just type in the service tag of the laptop and hit manuals, and you can either view or download their service manuals. And I think it's really great that they even release them for their Alienware line of laptops. They come in really helpful. If you get this particular model Alienware on your bench, don't let it intimidate you. It's a very heavy laptop. It's beautiful. It really is a nice looking laptop. But it's pretty easy, I would say, to take apart. So with the service manual that they provide and a little bit of patience, you know, don't get nervous about taking this laptop apart. It's been one of the easier ones for me. Okay, what this is a filler plate that they provide that goes into one of the slots where a video card would have went if this had 2 video cards, but this only has 1. And this is the actual video card. That's a beautiful card. That is a HD 6970M ATI card. And we'll go ahead and just install that. It just pretty simple. Just slides right into one of the SLI slots there. Push it down, put in a couple screws. Done. Here we go. Next up is our CPU heatsink. Now this still has the crusted up thermal compound still on it. We'll have to clean that off here real quick. Put a little bit of thermal compound removal solution on there. Spread it around. And we'll just simply just wipe that off. Wipe it clean. Good to go. Now I think it's important to point out to be careful when you're cleaning or putting any kind of pressure on the actual heat sinks on laptops. That's copper, yes, but it does bend and it can bend. Bending these in any way, shape, or form could be disastrous. It could seriously affect the cooling. So just be really careful when handling the heat sinks in laptops in general. Alright, we'll finish off this, cleaning off this guy here, getting every little bit off. It's really important to get all this stuff off because we want to make good contact on our nice fresh thermal compound that we're going to put on this CPU. Okay, now I know this has been gone over thousands of times from different people. Thousands of videos have been made on it, but this is my version. This is how I apply thermal compound to a CPU. I use a razor blade and I use Arctic Silver. Arctic Silver is my choice. So we'll just put a little bit on here, and that right there, that small amount is enough, plenty enough for both dies. Now I must point out, do not scrape your CPU. Do not let the metal touch the CPU. This is important. This is my method. The razor blade is just used to spread the compound thinly and evenly. I am not pushing down on this razor blade at all. Not one bit of this razor blade is actually touching any point surface of the die. I'm just sort of like floating it on top, and I'm holding it at a very steep angle. It's almost like spreading pancake batter, but it's very thin. And right there is all you need. There is absolutely no need to put any more than that, and actually too much thermal compound can actually work against you. Okay, now we're just going to very gently lay our CPU heatsink in place. Now you notice with these heat sinks that they're Each screw is numbered, and this is important because you want to go in angles. You want to start on one corner and go to the opposite corner, couple of turns, and then go up one to the one next to that, and then go to its opposite corner. So you want to do everything in diagonals. This keeps from cracking the die. Basically, it's just helping to provide nice, even pressure instead of just torquing down on one side of the chip. That's done. Now we have the magnesium cover. This is one of the final steps here. You just get it placed, and then we'll be able to do our wire management. And at this point, obviously, you want to be sure you're not pinching or crimping anything that might be in the wrong place. This is where you kind of double check your work. Make sure everything's exposed is where it needs to be. And actually at this point, I would test the laptop. Okay, the wire management here. We have the antenna wires. We have the video cable. All the other wires that belong there. We'll go ahead and install the fan to the CPU. And then we got the memory. We also got the back cover to this laptop that we'll put on here. And it's almost time to power on this laptop. So with a properly soldered power jack, now we know we have solid power going to this board. I think this laptop is going to have a whole new lease on life, so to speak. We'll just pop the old battery in and flip it over, and let's see how we do here. Again, you can test this laptop after you get your heatsink, CPU heatsink on, and your video card in. You can then test before you put it completely together. In my case, I went ahead and put everything together. We're going to open it up, and we're going to hit that power button, baby, and let's see what we got. Bingo. We've got full power. Everything's looking good. I also moved the power cord around, kind of wiggled it, twisted it to be sure that everything was connected right. Everything seemed to be just great. So, hey everyone, hit that like button and subscribe to my feed. I have much more computer repairs coming up in the future, so look for it. Thanks a lot. Bye.